Good morning, students. Chapter 5, Magnetism and Matter. Yes, we have completed chapter, but we will see some extra questions for extra preparation. Okay, see, a bar magnet is oscillating in Earth's magnetic field with periodic time t. If magnet is cut into equal parts normal to its axis and each part is again suspended in the same field, find periodic time for each part. Okay, see, first case 1. Case 1. You are given a bar magnet. You are given a bar magnet which is oscillating in Earth's magnetic field. So what is periodic time for this? Yes, periodic time. Periodic time. T, its equation is T is equal to, it is 2 pi under root I upon M. Where 2, that is 2 pi, that is fine. What is I? I is moment of inertia. Moment of inertia. I is equal to, yes, moment of inertia, bar magnet, a rectangular slab. And what is its magnetic moment of inertia? If you remember, it is ml square by 12. It is ml square by 12. Well, what is m? M, it is, sorry, I will write capital M. Okay, yes, it is mass, capital M is mass of magnet. And L is length of magnet. It is length of magnet. Clear about this? So yes, I is equal to, it is ml square by 12. What is M? Magnetic moment. Magnetic moment. Magnetic moment. M is equal to, yes, if length of this bar magnet is L, then magnetic moment M is equal to, it is P into L. Where what is P? P is pole strength. P is pole strength. And L is length of magnet. Clear about this? So yes, again, we have a bar magnet having periodic time T is equal to 2 pi under root I upon MD. 2, that is 2 pi, that is pi. Moment of inertia I is equal to ml square by 12. Magnetic moment M is equal to P into L, where P is pole strength and L is length and capital M is mass. Now, case 2. See, here it is. Case 2. If magnet is cut in two equal parts, if magnet is cut into equal parts, if magnet is cut into equal parts, normal to its axis, and each part is again suspended. If I have one magnet like this, it is north, it is south, and its length is L, and its mass is M. Length is L, and mass is M. Okay, and if I cut into equal parts, then see, what is mass of each part? Mass of each part is M by 2. What is length? Length of each part is L by 2. Yes or no? For each part, mass of each part is M by 2. Mass, length of each part is L by 2. So what are changes? See, T equation. 2, that is 2. Pi, that is pi. B, that is same magnetic field. I and M, the both changes. See, what is magnet moment of inertia of each part? Moment of inertia of each part. Moment of inertia of each part. I dash is equal to, see, what is moment of inertia is equation? ml square by 12. M means mass. Now what is mass of each part? It is M by 2. L, what is length of each part? L by 2. It's square. So yes, it is ml square by 12. Clear about this? Simple. Clear about this? Okay. So I dash is equal to 2 into 4. So it is 1 upon 8. M L square by 12. But what is ml square by 12? Ml square by 12 is I. So here I can say I dash is equal to I by 8. I dash is equal to, here it is I by 8. Clear about this? Yes. I dash is equal to, here it is I by 8. I dash is equal to, here it is I by 8. Now, it is moment of inertia. Now we have to find what is magnetic moment. New magnetic moment. New magnetic moment. How to find this new magnetic moment? See, m is equal to M dash is equal to, we know that when this magnet having fold strength P and B is divided along an axis normal to x-axis, then fold strength will remain same. Fold strength will remain same. Okay, just its length is half. Okay, so yes, fold strength remains same. So yes, here it is P. What is length now? L by 2. So we can say it is PL by 2. But what is PL? PL is magnetic moment. So it is equal to, it is M by 2. So magnetic moment of each part M dash is equal to, it is M by 2. Magnetic moment of each part M dash is equal to, it is M by 2. Clear about this? Clear about this? Okay. So yes, now we will find new. Now we will find new periodic time. Okay. Periodic time for each part. Periodic time for each part. T dash is equal to 2 pi under root I dash upon M dash, because it is placed in same magnetic field. So yes, is equal to, it is 2 pi under root. I dash means it is I by A. Yes, here it is I by A. M dash means it is M by 2, and here it is B as it is. Clear about this? So yes, it is 2 pi. In bracket we will have 1 upon 8, 1 upon 4. So it is 1 upon 4. I upon M. 1 upon 4 its value is 1 by 2. So it is 1 by 2. 2 pi under root I upon M. What is 2 pi under root I upon M? That is T. So here we can say T dash is equal to, it is T by 2. T dash, here it is equal to T by. Clear about this? Okay. So yes, it is one extra question in which you have to find periodic time for magnet. Okay. Yes, you have to remember equation and what each and every quantity indicates. Yes, P 2 pi under root I upon M, I moment of inertia. Moment of inertia. And magnetic moment, and B is magnetic field. Yes, in this case we have cut this magnet into equal parts. Into equal parts. Yes, if I say if this magnet is cut in 3 equal parts, then find what is periodic time. Then find what is periodic time. If you are also given, okay, I have 2 such magnets, they are placed one above each. Okay, then what is new periodic time? So yes, there are numbers of questions. There are numbers of questions with this method. Okay, first of all, for first magnet you have to write this, then how it is cut or how it is combined or how it is joined, you have to find new periodic time. Clear about this? Now we will see next question. Now next question, a bar magnet makes an angle of 45 degree with horizontal in a plane making an angle of 30 degree with magnetic meridian. Find the true value of dip angle. See here this 45 with horizontal, it is not dip angle, because true dip angle is in magnetic meridian. True dip angle is in magnetic meridian. Here what is given? See, I will explain. Here it is. We know that if it is magnetic meridian, it is magnetic meridian. Magnetic meridian. If it is magnetic meridian. Okay, if middle is aligned like this, means magnetic field of Earth, it is in this direction. Okay, then it's 2 components. One, here it is BH, and one, here it is B. Yes or no? And this angle with horizontal, it is phi. This angle with horizontal, it is phi. So what is true value of dip angle? See, true value of dip angle is when magnetic needle is in magnetic meridian. Okay, true dip angle is angle when needle is in, or magnet or bar magnet is in magnetic meridian, is in magnetic meridian. So yes, you have to remember this point. Okay, a true angle is angle that makes needle or bar magnet in magnetic meridian, in magnetic meridian. And yes, what is value of true dip angle? See, true dip angle tan phi is equal to, we know that tan phi is equal to, we know that it is BB upon BH. True deep angle phi is equal to, it is tan inverse. Here it is BB upon BH. Clear about this? It is true deep angle. True deep angle tan phi is equal to BB upon BH. Tan phi is equal to BB upon BH. Clear about this? Clear about this? Okay. Now what is given? See, you are given like this. You are given one plane. You are given one plane. Okay. See, a bar magnet makes an angle of 45 degree with horizontal in a plane with horizontal. So yes, a bar magnet makes an angle of 45 degree. Makes an angle of 45 degree. So this angle is 45 degree. This angle is 45 degree. A bar magnet makes an angle of 45 degree with horizontal in a plane, making an angle of 30 degree with magnetic meridian. It is not magnetic meridian. It is another plane. It is another plane. It is another plane. Okay. Yes. Where is magnetic meridian? Magnetic meridian is like this. It is magnetic meridian. It is magnetic meridian. Okay. Yes. This orange chalk is magnetic meridian. It is magnetic meridian. Okay. And yes, what is angle between? See, plane making an angle of 30 degree with magnetic meridian. So this angle is 30. So this angle is 30. Clear about this? Clear about this? Or yes, if I want to make one general theory, I will here say it is phi 1, and here I will say it is theta. Here I will say it is theta. Here I will say it is theta. Where phi 1 is deep angle in another plane. It is not true deep angle. It is not true deep angle. True deep angle is in magnetic meridian. True deep angle is in magnetic meridian. This deep angle is in another plane. So it is not true deep angle. So I have denoted by phi 1. Plane angle between theta. Theta is angle between. Theta is angle between magnetic meridian. Magnetic meridian and another plane. Clear about this? Okay. Phi 1 is deep angle in another plane, and theta is angle between magnetic meridian and another plane. Okay. Now, yes, it is figure out magnetic meridian BH and BB. Yes or no? So yes, here it is. It is BH. And here it is BB. Yes or no? Here it is BB. Now see, here it is. This BH makes angle theta with this component. Yes or no? With this component. Yes or no? This BH makes angle theta with this component. So it becomes BH cos theta. It becomes BH cos theta. Do you understand this? Okay, it becomes BH cos theta. Clear about this? Okay. So now in this another plane, what is deep angle phi? Deep angle in another plane. Deep angle in another plane. See, simple. As it is making angle phi 1. As it is making angle phi 1. How to write this? Yes, tan phi 1 is equal to, it is BB upon BH cos theta. BB upon it is BH cos theta. BB upon it is BH cos theta. Clear about this? It is BB. It is tan phi 1 is equal to, it is BB upon BH cos theta. But what is BB upon BH? BB upon BH is equal to tan phi. So here I can write tan phi 1 is equal to tan phi upon cos theta. Because here this BB upon BH is equal to true deep angle. So true deep angle tan phi is equal to tan phi 1 cos theta. Tan phi 1 cos theta. So yes, you have to remember this equation. The true deep angle tan phi is equal to tan phi 1 cos theta. Where what is phi 1? Deep angle in another plane, and theta is angle between magnetic meridian and another. Clear about this? Yes, you have to put value, that is 10, 45 and cos 10, 45 and cos 30. Yes, 10, 45, you know what is its value? Cos 30, yes, you know what is its value? Yes or no? Yes or no? Yes, you know it. Yes, you know it. So yes, you can easily find what is value of phi. That is true deep angle. That is true deep angle. Clear about this? So yes, it is one question which is based on true deep angle. Which is based on true deep angle. Okay? This equation you have to remember. Tan phi, that is true deep angle, is equal to deep angle in given medium and angle between them, like two mediums. Clear about this? Yes, students, watch regular videos, make regular notes. If you have any doubts, then yes, contact me 7574858001, and yes, do like, share and comment our videos, especially mine. Good morning, students. Chapter 5, Magnetism and Matter. Yes, see, extra questions. First, a magnet is horizontally in the magnetic meridian by a wire without any twist. If the supporting wire is given a twist of 180 degree at the top, the magnet rotates by 30 degree. Now, if another magnet is used, then a twist of 270 degree at top rotates magnet by 30 degree. Compare magnetic moments of two magnets. See here it is. Okay, two magnets. First magnet, suppose it is like this. It is magnet. It is magnet. Okay, a magnet is horizontally in magnetic meridian by a wire without any twist. This wire is initially without any twist. If the supporting wire is given a twist of 180 degree at the top, if the supporting wire is given a twist of 180 degree at the top, magnet rotates by 30 degree. Magnet rotates by 30 degree. If you give this wire 180 degree twist, then yes, this magnet moves 30 degree twist. So what is resultant deflection? What is resultant? What is resultant twist? Resultant is 180 minus 30. So it is 150. So it is 150. Clear about this? So it is for first magnet. For second magnet, okay, in same magnetic field, if this wire is given twist of 270 degree, the magnet again rotates by 30 degree. So in this case, what is resultant? What is resultant twist? Okay, here resultant twist del 1 is equal to, it is 180 degree minus 30 degree, it is 150 degree. Clear about this? Clear about this? Okay. In this case, what is resultant twist? In this case, resultant twist del 2 is equal to, here it is 270 minus 30. 270 minus 30. So it is equal to, it is 240. Clear about this? Okay. So yes, this wire is twisted by 180 degree. Magnet rotates by 30. So what is resultant twist produced in this wire? Del 150 degree. In this case, it is 240 degree. Clear about this? Clear about this? Okay. Now, yes, if you have observed, if you produce twist in any string, in any wire, okay, if you rotate any wire like this, and if you release that force, then yes, we know that restoring torque is produced. What is produced? Restoring torque. So I am assuming that restoring torque is K. Let restoring torque per unit, restoring torque per unit twist is K. Let restoring torque per unit twist is K. So in this case, what is restoring torque? In first case, for first magnet, what is restoring torque? What is restoring torque? So yes, that restoring torque tau 1 is equal to, it is K del 1. Clear about this? For second magnet, restoring torque tau 2 dash, or it is tau 2, it is k del 2. Clear about this? Clear about this? So yes, resultant twist, restoring torque. Now, as they are placed in magnetic field, see, this magnet rotates by 30 degree. This magnet also rotates by 30 degree. We know that whenever magnet or needle, they are freely suspended in magnetic field of Earth, they will align in direction of magnetic field of Earth, that is in magnetic meridian. So due to Earth's magnetic field, horizontal component of Earth's magnetic field, there is some torque acting on magnet. So in this case, what is torque acting? What is torque acting on magnet due to Earth's magnetic field? Torque due to BH. You know what is BH? Horizontal component of Earth's magnetic field, and that is tau 1 dash is equal to, yes, it is M1 BH, MB sine 30. Why 30? This magnet is rotated by amount 30. Yes or no? Yes, it is. Clear about this? Okay, M1, because we are given two magnets. So for first magnet, that magnetic moment is M1 BH. Earth is same for two magnets, so horizontal component of Earth is same. For this case, what is torque acting due to BH? Torque acting due to BH. It is tau 2 dash is equal to, it is M2 BH sine. Clear about this? Okay. Now see, on this first magnet, two torques are acting. First, due to twist produced in wire, and another is torque due to Earth's magnetic field. This torque is due to twist produced in wire, and this torque is due to Earth's magnetic field. In equilibrium condition, we know that resultant torque is 0. Resultant torque 0, it means restoring torque produced due to twist is equal to torque produced due to magnetic field. So I can write here, it is tau 1 is equal to tau 1 dash. Similarly, for second magnet, tau 2 is equal to tau 2 dash. Clear about this? Now if I take ratio of these two equations, then see, it is tau 1 dash, here it is tau 2, here it is tau 1 dash. Tau 1, where is tau 1? Yes, here it is k del 1, here it is k del 1. Tau 2, here it is k del 2, is equal to tau 1 dash, it is M1 BH sine 30 divided by M2 BH, here it is sine 30 cut, BH cut, K cut. What is del 1? Yes, del 1 is 150 degree. You have to convert this degree in radian by multiplying pi by 180. Yes, by multiplying pi by 180. But pi by 180 will cancel out. And yes, we will have only 150 upon 240 is equal to 150 upon 240 is equal to this M1 upon M2. 0 cut. So what is value of M1 upon M2? M1 upon M2 is 15 divided by 24. It is 15 divided by 24. And yes, it is your answer. And yes, it is your answer. Clear about this? Yes, further you can simplify this. 15 and 24. 15 and 24. 15 means, yes, it is 5 into 3. It is 5 into 3, and 24 means it is 8 into 3. Yes or no? Yes or no? So yes, it is 3 cut. So it is 5 by 8. So yes, it is one question which is based on equilibrium of magnet. Okay. Now second question. See, here it is. The work done for rotating a magnet with magnetic dipole moment by 90 degree from magnetic meridian is n times the work to rotate by its 60 degree. See, work to rotate 90 degree from magnetic meridian is n times work to rotate by 60 degree from magnetic meridian. Okay, we know what is equation of work done. Yes, equation of work done here it carries MB cos theta 1 minus cos theta 2. In magnetic meridian it makes angle 0, so it is cos 0 minus cos 90. Yes, you know this equation. MB cos theta 1 minus cos theta 2, okay, is equal to, here it is n times, here it is n times, MB, yes, you have to write MB, here it is cos 0 minus cos 60, that is cos 0 minus cos 60. Here about this, you have to remember equation of work, that is W is equal to MB cos theta 1 minus cos theta 2, cos theta 1 minus cos theta 2. Clear about this? So now see this MB cut, this MB cut. Now cos 0, here it is 1, cos 90 is 0 is equal to, it is here it is n, cos 0 it is 1. What is cos 60? Yes, it is 1 by 2. So 1 is equal to n, here it is 1 by 2. So n is equal to 2. N is equal to 2. Clear about this? So yes, it is one simple question which is based on this equation, that is W is equal to MB cos theta 1 minus cos theta 2. Clear about this? Okay, so yes, we have these two extra questions. Now we will see another extra question. See. Now see, next question. A magnetic needle is hung by an untwisted wire so that it can rotate freely in magnetic meridian. In order to keep it in the horizontal position, a mass of 0.1 gram is kept on one end of needle. If the pole strength is 10 ampere meter, then find vertical component of Earth's magnetic field. G, you have to get 9.8 meter per second square. See, we know that when we place a magnetic needle in magnetic meridian, what happens? It is magnetic meridian. It is magnetic meridian. Okay. If we place needle, it will align like this. It will align like this. Okay. Yes. It is not pole and it is south pole. Magnetic needle aligns in this direction because it is resultant magnetic field of Earth. We know that it is horizontal component of Earth's magnetic field. It is vertical component of Earth's magnetic field in this direction towards center. It is in horizontal direction. Okay. Yes, this needle, it is at some angle with horizontal, not in horizontal direction, and it is called deep angle. Yes, you know this figure. Magnetic needle in magnetic meridian, it is tilted with this horizontal direction, okay, at some angle phi, that is called deep angle. Now what is question? Here it is. In order to keep it in horizontal position, a mass of 0.1 gram is kept on one end of needle. Yes, you have to put mass 0.1 gram on this end of needle. So if you put mass here, on that mass, gravitational force mg is acting in vertically downward direction. So yes, this needle will rotate, and it will align in horizontal direction. It will align in horizontal direction. Clear about this? So yes, you have to put that mass on this south pole, on this south pole. Okay. Now if you put that mass, what happens? See here again, it is magnetic meridian. It is magnetic meridian. Okay. If you put mass on this end, if you put mass here, okay, that mg will act in downward direction, then this magnetic needle will align in horizontal direction like this. Like this. This magnetic needle will align like this. Okay, clear about this? In horizontal direction. In horizontal direction, let it is O, that is center of magnetic needle. Now we have to identify numbers of forces acting on needle. See, first of all, due to this mass, mg is acting in vertically downward direction. Yes or no? Yes, it is. Okay, then this magnetic needle, see, it is rotating in this direction. If I release this mass, then what happens? Then yes, this magnetic needle will align in this direction again. It will align in this direction again. So yes, there is some force acting on this pole in downward direction and some forces acting on this pole in upward direction. Again, if I take this mass from this end, then what happens? This magnetic needle will align like this. Means force acting on this pole, it is in vertically downward direction. Force acting on this pole, it is in vertically upward direction. Yes or no? And yes, as these forces are moving in vertical plane, these forces are due to vertical component of Earth's magnetic field. If pole strength is P, force acting on pole, F is equal to PB. Here on this pole, force is acting due to vertical component of Earth's magnetic field, so it is PBB. Clear about this? On this pole, force is acting, it is PBB, because pole strength is same and magnetic field of Earth it is also same. Clear about this topic? Okay, so yes, three forces are acting, PBB, and mg. Now, yes, it is magnetic needle. Its length we are assuming 12. So this length is L, this length is also L. So yes, here if I indicate length, then yes, this length is L, this length is also L. Clear about this? Now, as this needle is in horizontal condition, it is in equilibrium. Okay, needle is in horizontal position. It means it is in equilibrium. And we know that for equilibrium with respect to this point O, sigma tau is equal to 0. Resultant torque is 0. Now torque is vector quantity. Okay, due to these three forces, torques are acting. Okay, so yes, what is direction of torque? See here carefully. Torque, due to which object is performing rotational motion in clockwise direction. Like this. In clockwise direction, I have to consider positive. And torque, due to which object performs rotational motion in anti-clockwise direction, I will consider negative. Clear? Now how to find torque? Torque is equal to this force into distance. Chalo, first of all we are taking this force, that is PBB. Okay, distance from this center is O. So means it is PBB into L. Now positive or negative? See, here it is. Due to this PBB force with respect to O, this magnetic needle will rotate in this direction. How? See, it is point O. PBB is acting in upward direction, so needle will rotate like this. Again, it is point O, needle will rotate like this. So yes, it is in clockwise direction. So torque acting due to PBB, you have to consider positive. So yes, it is PBB, that is force. What is distance from this point O? It is L. Clear about this? Okay. Now second one, PBB. See, here it is center O. It is O. PBB forces acting in downward direction. So again, it is in clockwise direction. So it is also positive. It is PBB. BV into L. It is PBV into L. Clear about this? Now last one, that is mg. mg, yes, due to mg. See, point O, mg is acting in downward direction. So it will perform rotational motion in anti-clockwise direction. In anti-clockwise direction. So I have to take it negative. So it is minus. So it is minus mgl. It is minus mgl is equal to 0. Minus mgl is equal to 0. Now 2pbvl is equal to mgl is equal to mgl. 2pbvl is equal to mgl. L cut. If you make bv as subject, then bv is equal to, it is mg upon 2p. It is mg upon 2p. M mass 0.1 gram. So it is equal to 0.1 into 10 raised to minus 3 gram. You have to convert in kilogram. G, yes, G, it is 9.8 divided by 2. P, what is P? Here it is 10 ampere meter. So it is 10. It is 10. Clear about this? And yes, if you calculate this, you will get your answer. It is 4.9. It is 4.9 into 10 raised to minus 5 Tesla. Into 10 raised to minus 5 Tesla. Clear about this? So yes, it is one question which is based on, see, this combination of standard 12, chapter 5, magnetism and matter, and chapter number 7 of 11th. Yes, it is about equilibrium of torque. Equilibrium of torque. Clear about this? So yes, again, it is one important question that you have to study. Okay, now, yes, student, with this chapter 5, that is magnetism and matter, is complete. Now, from next lecture, we will start our next chapter, that is chapter number 6. Okay, that is EMI. Okay, electromagnetic induction. Okay, all the best.